Okay, some of you guys said that you would need help with number 6, 7, 8, and 9. So real briefly, I'm going to do those for you real quickly. On number 6, it says an object starts from rest with a potential energy of 600 joules and free falls toward the ground. After it's fallen to a height of 1/4 of its original height, its total mechanical energy is what? Well, so at that point, what is its total mechanical energy? Remember, guys, what we said in class, that anytime gravity is the only thing doing work on our object, total mechanical energy stays constant or stays conserved. So if we start off at rest, that means at the very top, we have 0 kinetic energy and 600 joules of potential energy. Remember what total mechanical energy is potential energy plus kinetic energy, which in this case has to be equal to 600. And so since our total mechanical energy stays constant, that means we have 600 joules of total mechanical energy when we come to 1/4 of our original height. So the question is, what is the potential energy at that point? Well, let's think about it like this. So if an object starts off from this height here, and at this height it had 600 joules of potential energy, and it fell, so the object fell and it dropped all the way to here, which is a point that is 1/4 of its original height, so somewhere around here, along this line here. The question is, what is the potential energy here at that point? Well, think about this for a second. If we start off here and we dropped our object and it fell all the way here, so it lost height. If it lost height, that means it lost potential energy. What was the potential energy at that point? Well, it had to be 1/4 of its original potential energy. So you would take 600 and you would divide it by 4, and that gives you 150 joules of potential energy at that point. And again, the reason why you know that, because at this point here, if we started off here, at this point here, we're 1/4 of our original height, therefore we have 1/4 of our original potential energy. So that means the potential energy at this point is 150 joules of potential energy. Now the question is, what is his kinetic energy? What is his kinetic energy at that point? Well, remember, kinetic energy plus potential energy has to equal the total mechanical energy. So 100 plus 450 joules gives you a total of 600 joules of total mechanical energy. Okay, so that's number 6. Let's move on to the next one. It says, consider the diagram at the right in answering the next 3 questions. 5 locations along a roller coaster track are shown. Assume that there are negligible friction and errors as the forces acting upon the coaster car. Okay, guys, so here we have a roller coaster. Starts off at rest, and it goes down this hill here and goes in these 2 loops here before going up this hill and coming out over on this end. It says, rank the locations in order of increasing total mechanical energy. Well, that's easy because total mechanical energy, since gravity is the only thing doing work on this roller coaster, total mechanical energy has to stay conserved. So that means the total mechanical energy at A is equal to the total mechanical energy at B, which is equal to the total mechanical energy at C, which is equal to the total mechanical energy at D, which is equal to the total mechanical energy at E. Okay, so total mechanical energy at every point along this roller coaster stays constant. What about here where it says rank the 5 locations in order of increasing potential energy? Well, potential energy, the one that has the greatest potential energy is the one that has our greatest height. So that clearly has to be A. So A has more potential energy than point C, and that's the next height. That's the next highest height. And then which has greater potential energy at D, which has greater potential energy at E, and the last one to be ranked is our is point B, because notice that's at ground zero. We have no potential energy at that point. Number 9 says rank the 5 locations in order of increasing kinetic energy. Well, our greatest kinetic energy should be at point B, because that's at the very bottom. That's at the point where all of our potential energy has been converted to kinetic energy. So B is greater than E, which is greater than D, which is greater than C, and which is greater than A. So it's nothing more but the potential energy in reverse. Okay, so that's our rankings. Now lastly, just looking at the last one, on number 10, once again we have a roller coaster track here. And so after filling out these blanks here, we need to fill out these bar charts below. I'm just going to go ahead and get you guys started here. I want you guys to notice something here. So point A is our highest point, and then we slide all the way down to our lowest point here, where our roller coaster has gained. So it's gone from all potential energy here to all kinetic energy here, for going back up this loop here and over this hill here and here. But I want you guys to notice something here. This height is the same thing as this height, which is the same thing as this height. So notice at the very bottom here, our roller coaster has all kinetic energy, meaning at the very top we have to have all potential energy. So the total potential energy here has to be 40,000 joules, right? Because we started out with all potential energy here. What about this? What about at the point B here? Well, what is the kinetic energy at that point? It's easy. You know, remember potential energy plus kinetic energy has to equal the total energy. And the total energy is 40,000 joules. That means our kinetic energy here must be 20,000 joules. Okay, and so you guys should be able to fill out the rest. If you have any questions, don't hesitate to contact me.